Welcome back to section 5.3. Section 5.3, we're going to talk a little bit more about adding, subtracting, and multiplying polynomials. So again, using some of the properties we learned in section 5.1 on properties of powers and the like, and also being able to combine like terms. This really should be nothing new. Again, we talked about combining like terms way back in chapter 1, but it's certainly not a bad idea to revisit these ideas as they get a little bit more complicated. So the first thing we want to do is we want to talk about adding polynomials. And when we talk about adding polynomials, there's really two different formats that the book will kind of talk about, and there's a vertical format and a horizontal format. The vertical format says, look, if I had the sum of 3x to the third minus 2x squared plus 4x minus 6, and I wanted to add to that the polynomial x to the third minus 5x squared plus 3, I would align those things in a column that are common terms and then simply add down the columns. All right, so this becomes 3x to the third plus 1x to the third, which is 4x to the third. Now be careful here, these are both negatives, so negative 2x squared minus 5 more becomes negative 7x squared. Since there are no x to the first power terms in the second polynomial, this 4x simply just becomes a plus 4x. And then on the very end here we have negative 6 and 3, which is negative 3. Now, they talk about the vertical format, and like I said, you just rewrite it so that those things are on top of each other, and then you combine like terms. Another way you can do it again is if you're adding this whole thing together, then essentially these parentheses are only there and only meant to be there so that you can kind of keep track of which polynomial is which, but they're really essentially worthless when we're adding. We're going to talk about what they mean when we subtract in just a moment here. But what we're going to do then is we're going to group those things that are common. And so the first thing I'm going to do is I'm going to find all of the 2y to the thirds. And in this case, there are no more 2y to the thirds, or any y to the thirds for that matter. So this is simply 2y to the third. All right? Now once I've done that, I'm going to cross it off so I'm not tempted to use it again. Now let's go to y squared. Let's move to the next degree. So the next degree then is 7y squared and negative 4y squared, which becomes plus 3y squared. And once again, once I've done that, I'm going to cross those off. Now let's look for y to the first powers, or first degree powers of y. This is minus 3y, because again, you have negative 6y and positive 3y, which make negative 3y. And as we continue to work through this, you can kind of see that the only thing left over is the minus 9 on the end. All right, so those are the two formats they talk about in the text, both adding horizontally and vertically. Let's talk for just a second about subtracting polynomials. Now, when you subtract a polynomial, you have this individual polynomial here, and you're subtracting the entire second polynomial. You're subtracting all those quantities. So to subtract a positive 6x to the third means to add a negative 6x to the third. To subtract a positive 3x to the third says that you're going to, you know what, we need to change this. This must be a typo in their notes here, guys. This should be a squared. This should be 3x squared. And I think there's another one coming up here shortly, but I wouldn't have noticed that. So again, we're adding a negative 3x squared. Now, to subtract a negative 7x really means to add a positive 7x. And to subtract a positive means to do a negative. So basically, when you do the vertical method, the way that I would do the vertical method is essentially I would say, look, since I'm subtracting this entire polynomial, I'm going to rewrite it and basically switch all their signs. So it becomes negative 6x to the third, negative 3x squared, positive 7x, and then on the end we have minus 5. So all of these signs in here essentially just get switched. Because when you're subtracting, again, we're going to adding the opposites. So we're just going to add the opposites of all of those now, like we did before, and now we're adding down the columns. So this becomes 1x to the third. If you want to just put x to the third, that's fine. You have negative 6x squared and negative 3x squared, which becomes negative 9x squared. You have positive 7x and negative 3, which is positive 4x. And then positive 7 and negative 5 is plus 2. All right, so that's the vertical format, and again, it just says line them up so that they match up. And again, I apologize for that typo right there in those notes. All right, in the horizontal format, if you don't feel like rewriting this so that things are on top of each other, again, what we can do is we can say, look, this is the same thing as adding the opposites of all of these. So I'm just going to make this subtract sign into plus, and then take the opposites of everything in the second set of parentheses. So now, once we've done that, we can, like we did previously, we can just dump the parentheses because they're essentially worthless. And so this becomes negative 12x squared plus 9x and plus 3. And now, like we did before, let's just group those things that match. All the x squareds are here and here. So this is negative 4x squared. Cross them off. Now let's go to x's. You have positive 9x and negative 5x, which becomes plus 4x. Cross them off. And now I have positive 11 and positive 3, which is 14. All right, and so that is adding and subtracting. Why don't you guys try a couple on your own, and then we'll come right back with solutions for adding polynomials. All right, so I'm going to do the horizontal method just because it saves me a little bit of time and space. Instead of subtracting this entire polynomial, we're going to add the opposite. So I'm going to have plus a negative 2x to the, or 2t to the third, a positive 3t squared, and a negative 7t, or just negative 7, sorry. And so now I have to group those things that are common. Now, pay special attention because the first one is not in standard form. Remember, standard form says the polynomial has decreasing exponents as we go from left to right. This one is not. So the only t to the third problem, or the only t to the third term in the entire thing is right there. This is negative 2t cubed. Cross it off. Now let's go to t squared. So here's a negative 5t squared and a positive 3t squared becomes negative 2t squared. Cross it off. All right, and now let's go to my t to the first powers. There's only one t to the first power in the entire problem. It's that 8t right there. And now we have a positive 6 and a negative 7, which makes negative 1. All right, the second one, since we're adding, we don't have to worry about these parentheses at all. Okay, and again, I'm going to stick with the horizontal format. I'm just going to find all the p squareds. They're both positive, so this becomes 12p squared. Cross them off. Let's go to p's. Negative 6p and negative 7p is negative 13p. Cross them off. And then negative 6 and positive 4 becomes negative 2. All right? Okay. As we move into the next page, then I want to talk a little bit about multiplying polynomials. And the book calls for this horizontal and this vertical format. And to be quite honest with you, I don't like either one of them. When you're multiplying, what they're going to say to do is to do the horizontal format. Way back when you were like a little kid, you learned to multiply like 24 times 3. You would do 3 times 4 and get 12, carry the 1, 3 times 2 is 6, and I'm sorry, 7. And 6 plus the 1, which is 7, and so you get 72. Yeah, way back when you were kids, right? So you can multiply those two quantities together using that kind of method. So when they talk about multiplying in the vertical format, really they're saying, look, double everything, all right, and then multiply everything by x. And that method does work, and it's certainly valuable. And so you can use that methodology if you want. I have been a big proponent of using what we would call a Punnett square. Obviously, in this case, since this is a binomial and this is a trinomial, we actually have a rectangle. And so it doesn't matter. Multiplication is commutative, so the order can be switched. I'm going to put the x plus 2 down the side, and I'm going to put the 3x squared here, minus x, and plus 4. And now it simply says to fill this box here, I multiply these two things together. This is 3x to the third. X times negative x is negative x squared. X times 4 is 4x. And so on and so forth. You get 6x squared, negative 2x, and positive 8. Now, provided this is in standard form and these exponents decrease and I'm not missing any, meaning I don't have like x squared and then no x's and then all the way down to the constant there, you know, these typically are going to be like terms here, all right? They don't always work that way, but typically, again, if this is in standard form, decreasing, and there's no holes, again, you've got x squared, x is the first, and then no x's, and then so on and so forth. These will be like terms. But combine like terms in the chart, just sort of like we did either the horizontal or vertical method. You can rewrite it if you want, but this is then 3x to the third. That's the only x to the third problem, or term in the whole problem. So we're going to cross that one off. Now we have 6x squared and negative x squared, which becomes 5x squared. Now I have 4x minus 2x becomes 2x. And then you got this lonely 8 on the end. And so again, this is 3x to the third plus 5x squared plus 2x plus 8. Once again, they're going to try to show you another method, again using the horizontal method. Basically, they say you're distributing x minus 3 to all three terms. So everything gets multiplied by x minus 3. And then you would have to then distribute this term. This gets really confusing, right? So instead of doing all of that, what I'm going to do instead is I'm going to use my FOIL method again, or I'm sorry, my Punnett squares method again. I'm going to clean this off over here. So you may have to put that work someplace else. But let's go ahead and take a look at letter B here. I want to write letter B as the product of two polynomials. I'm going to put the x squared here. I'm going to put the 2x here. and the minus 5 there, and then x minus 3 there. All right, so this becomes x to the third. This becomes 2x squared. This is negative 5x. This is negative 3 times x squared is negative 3x squared. Negative 3 times positive 2 is negative 6x. Negative 3 times negative 5 is positive 15. Watch your signs. So then, the only x to the third term in the entire problem is right there. This is x cubed. Cross it off. Negative 3x times positive 2 is negative 6x squared. Cross them off. Negative 6x and negative 5x becomes negative 11x. Cross them off. And you still have your plus 15 on the end. And that saves you a lot of time and trouble of trying to distribute and keep track of all of that stuff. Again, potentially a little bit confusing. All right? Now, what if they ask you to multiply 3 binomials? All right? You have 3 binomials all being multiplied by one another. The book says to basically distribute that to all of these terms and then take that result. Again, I don't subscribe to any of this. I think this is all garbage. To me, I would much rather use something I'm familiar with. All right? And so I'm just going to take the first 2 and multiply them together. X minus 3 and x plus 7. Multiply the first 2 binomials together. The result will be a trinomial. And then multiply that result by the x plus 1. All right? So let's do the first 2 together first. X minus 3 times x plus 7. This becomes x squared minus 3x plus 7x and minus 21. And that simplifies to x squared plus 4x minus 21 when I combine like terms. All right? So now that's the product of the first 2. So now I still have to multiply that by x plus 1. And so again, I'm going to make my little rectangle here. And this is x squared plus 4x minus 21. And this is x plus 1. We'll go here. All right, x times x squared, x cubed. X times 4x, 4x squared. X times negative 21 is negative 21x. 1 times x squared is x squared. 1 times 4x is 4x. And as you can imagine, 1 times negative 21 is negative 21. Now we just have to combine like terms. And so as I look here, I find only 1x to the third problem, or 1x to the third term. So x to the third. Now we have x squared and 4x squared. Remember, that's 1x squared, so that's a total of 5x squareds. As far as x to the first power, you have negative 17x to the first power, because negative 21 and positive 4 makes negative 17, and you got that lonely negative 21 on the end. All right, so that's how I would approach those using the Punnett squares. Definitely there are other methods, but probably as far as ease of use, that's probably the easiest one. All right, we've learned all of these patterns. We learned these in Chapter 4 when we talked about factoring. Now we're going to go the other way, and we're actually going to be performing the multiplication. So we're expanding now. Before, we factored. So last time we took them from something that was like this, and we went this way. Now we're going this way to here. So whenever you have the sum and the difference, we call it the sum and difference pattern. It becomes the first thing squared minus the second thing squared, so this becomes x squared minus 4. Because again, when you do your FOIL, you get x squared. Negative 2 and positive 2 don't have any x's left, and then this is negative 4 on the end. All right? Square of a binomial product becomes the first, whatever this is, squared. Okay, whatever this is, squared. And then, since you're going to end up with y plus 4 squared means y plus 4 times y plus 4. So when you do y times 4 and 4 times y, you're going to get 4y twice, which is plus 2 times 4y. And then 4 times 4 is 16. And then we can simplify 2 times 4 to simply 8y. All right, and so that's where this double, the product of a and b, comes from, because you're going to get 4 times y and y times 4. You're going to get that twice. And so it's double the product of y and 4. Again, the same thing for the next one. This is 3p squared minus 2. And so it's the first thing squared, which is 9p to the 4th. All right. And then on the end of that, that's whatever negative 2 squared is, which is 4. And then we just have to figure out the term in the middle. Well, it's 3p squared minus times negative 2. That's negative 6p squared, but I'm going to have 2 of those. And so it's negative 12p squared. And then when I square negative 2, I get positive 4. All right, so those are nothing new. Again, those are the factoring patterns that we learned in the previous chapter. We're now expanding them, so we're kind of going the other way. The ones that are a little bit more confusing are this idea of the cube of a binomial product. Now, you can certainly check this if you don't agree with me. A plus b, if I was multiplying a plus b, and I was doing that 3 times, I would get the result of this, and then whatever that would be, for example, a squared, ab, and then b squared. And so this would become a squared plus 2ab plus b squared. Now, once I had that, again, I've only done a plus b twice, so now I'd have to multiply by another a plus b, and so I can make my little Punnett square, a plus b, and then I would put this on top of this. And when I FOILed all of this out and expanded and all that, when it all got simplified and in the wash, we'd get something like this. All right? So it's whatever the first term is cubed, and then this is my first term and my second term are called a and b. And I'll get to an example in just a minute where they're not first term, second term. It'll make a little bit more sense. So it becomes whatever the first term is cubed plus 3 times, and then watch the powers of a. It was a to the third, a to the second, a to the first, and then no a's. My b's go from no b's, b to the first, b to the second, b to the third. So my powers on the first term steadily decrease, all right, as we go left to right, and my powers of b steadily increase as I go left to right. All right? So the first term becomes whatever the first thing is cubed. Well, in this case, it's x cubed. Plus 3 times, and again, what I'm going to do is I'm going to reduce the power on this by 1, so making it x squared, and then I'm going to take the power of that and increase it by 1, so that's times 1. We'll simplify in just a second. Now, again, we have plus another 3, and it's this thing now to the, again, this was third power, second power, now it's x to the first power, and then 1 is now being raised to the second power, while 1 squared is still 1. Again, we'll deal with that in a second. And on the very end of this, then, now my b goes from, remember, in the first problem, there weren't any b's, there were no 1s. Now there's 1 to the first power, 1 to the second power, and so on the end it's 1 to the third power. So those powers steadily increase on the second term, and they steadily decrease on the first. Now we just have to simplify. So this is 1 to the first power, which is, again, 1 times 3, which is 3. And so this becomes x to the third plus 3x squared. 1 squared is still 1, and so it's plus 3x plus 1. All right? Now, what if it's a minus sign? Well, the same thing applies. You could do this. You could really just memorize this one pattern and make this plus a negative and then deal with it that way. The book teaches it as a separate pattern. I don't really know if we have to. If it's minus 3, again, we're going to start with r to the third power, and then we're going to plus 3. And again, we take r and we square it, and then our second number here, again, our b, if I change this to plus a negative, it's just negative 3 to the first power. Plus 3 times, now we're going to go from r to the third, r to the second, now it's r to the first. And this is now negative 3 to the first, now this will be negative 3 squared. And then on the very end of this, again, there are no more r's left, we don't need the 3 anymore, and so it's simply negative 3 cubed. All right, so you can memorize the pattern, or you can memorize how the pattern works. Again, the powers of the first thing are reduced, 3, 2, and 1. The powers of the second one steadily go up. There are no negative 3's here, but then it's negative 3 to the first, negative 3 to the second, negative 3 to the third. Now we have to simplify. The first term doesn't change, that's r cubed. 3 times r squared times negative 3, well, negative 3 to the first is negative 3, times 3 is negative 9, r squared. Negative 3 squared is positive 9, all right? So this becomes positive 9 times 3, which is positive 27r. And then on the last term, this becomes negative 3 cubed, which is negative 27. All right? So those are the patterns. Let's actually use them on the top of the next page. All right? First of all, the first one is the sum and difference pattern. Again, sum and difference, and we have the same thing in both spots. So it essentially becomes 7m squared minus 3 squared. This is 49m squared minus 9. Make sure you square both things inside of there. Remember, that's the power of a product property. We are squaring 4t to the third. So you can write this out. You can do this. You can do 4t plus 6. I'm sorry, 4t cubed and 4t cubed plus 6, and you can do this way. Or we can use our special patterns. And again, I told you there was another typo here. This needs to be changed to a 2. All right. So what it does is it becomes the first thing squared, so 4t cubed squared. The last thing squared is there, and then the middle is twice the product of what I squared here and here. and so this becomes 4t cubed and 6. All right, basically these two terms. All right, and so the first term becomes 4t cubed squared. Well, again, power of a power says this is 16t to the 6th. This is 6 times 4 times 2. That comes out to 48t to the 3rd. And then 6 squared on the end is 36. All right, and now finally for the last one, remember in this pattern business, when we're looking at the square of a, the cube of a binomial, this gets really complicated. And so I don't like this methodology that they're asking us to fill in here. I know that the first term, my a, that's my a, and that's my b. The powers on a are steadily going to decline. The powers on b are steadily going to increase. And again, I need a 1. The coefficients are a 1, a 3, a 3, and a 1. All right? So I need 1, and then I have xy to the 3rd power, and there are no negative 4s. Again, I'm going to make this plus a negative 4. And there aren't any negative 4 to the basically it's negative 4 to the 0, but we don't really bother writing that in there. All right? So the next term becomes 3, coefficients of 3 there. All right, and so now we want xy squared, because I went from 3rd power to 2nd power. And now there weren't any negative 4s in the first one, so now there's a negative 4 to the 1st power. In the next term, I have again a plus a 3, and this is now xy to the 1st power, because again, my powers on xy go from 3 to 2 to 1, and there aren't any on the last one. And I'll have to put that last term down here, by the way. And then this is negative 4 squared. Because again, my powers of negative 4 were 0, 1, and 2. And then finally on the last term, there are no xy's. Again, this was 3, 2, 1, and so there'll be no xy's. But I will have negative 4 to the 3rd power. And so now I've got all this mess and I need to simplify. In the first term, this is x to the 3rd, y to the 3rd, which is x cubed, y cubed. In the second term, we have negative 4 to the 1st power, which is negative 4, and negative 4 times 3 is negative 12. And now you still have this x squared, y squared, so this is x squared, y squared. That term is taken care of. Now we have our 3. We have negative 4 squared, so negative 4 squared is positive 16, and then I'm going to multiply that by 3. 16 times 3 is 48, and you have xy to the 1st, which is plus 48xy. And then finally on the end, you're going to have xy, there are none. You've got your 1 here. Negative 4 to the 3rd is simply negative 64. And so again, you don't have to memorize a sum and a difference, especially if you just treat those powers as declining. These powers go down, the degrees go down, these degrees go up as you work through your problem. All right, so a couple of checkpoint problems here, and this will probably be the longest part of the lesson. So I won't go through the solutions for these. I'll have you try them all, and I'll come back with answers, and then if you have questions, you can ask those questions during class on the following day. All right, so when I go ahead and I multiply on number 3, I'm going to get 6x to the 3rd minus 9x squared minus 11x plus 10. And again, I would use Punnett squares here, and I would put the x minus 2 here, and I would put the 6x squared plus 3x minus 5 there, and then get all your entries and combine like terms. Same thing for number 4. You would do the Punnett squares to multiply the first two together first, x plus 3 and x minus 6, for example. And it doesn't matter what order you do them in. You get whatever that trinomial is, and then you multiply that by x plus 5. The resulting polynomial for multiplying the first two is x squared minus 3x minus 18. And then you would again make another Punnett square, which is really a rectangle, and you do the same thing again. Altogether, you end up getting here x to the 3rd plus 2x squared minus 33x minus 90. All right, again, this is the square of a binomial product. This one isn't too bad to do if you want to just go ahead and do this one together. This is going to be 36q squared. And then on the end of it, it's going to be plus 9r squared. And then in the middle, it's going to be twice the product of those two. Well, the product of 6q and negative 3r becomes negative 18qr. And then I have to double that, so it's minus 36qr in the middle. And then finally, the last one is one of these cube of a binomial. And like I said, I think these ones probably will take the longest. But it is, remember our coefficients are 1, 3, 3, and 1. And now what we have to do is we have to take the powers of 2m and decrease them from 3. There are no 5s. 5 to the 0 power, remember anything to the 0 power is 1. Now my powers on 2m are going to decrease, so going from 3 to 2. My power on 5 is going to go from 0 to 1. My powers on 2m decrease from 2 to 1, and this is now 5 squared because I went 0, 1, 2. And now in the last term, this is then, there are no 2m's, and there are 5 to the third. All right, so again, my exponents on the first term steadily decrease, 3, 2, 1, 0. My exponents on the second term increase from 0, 1, 2, and 3, and my coefficients are 1, 3, 3, and 1. All right, now let's simplify. This becomes 2m to the third. This is not 6 here. Make sure you do 2 to the third, which is 8, and m to the third, which is m cubed. Now I've got some simplifying to do in here because this is going to be 2 squared, which is 4. We're going to have the m squared. I can get the m squared out of that. All right, but now I've got to have 3 times 4 times 5. And 3 times 4 is 12, times 5 more is 60, and so you're going to get 60m squared. So that term's good. 5 squared is 25. I got to multiply that by 2 to the first, which is 2, and I still got to multiply that by 3. All right, and so this becomes 3 times 2, which is 6, and 6 times 25 is 150, and I still have just m to the first power. We don't have to put the plus there, the 1 there, if you don't want to. And then finally, for the last term, it's 1 times 2m to the 0. Well, anything to the 0 is 1. So this last term is basically whatever 5 cubed is, which is 125. All right? And so that is lesson 5.3.